Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. In this episode, we're talking about microservices with Christian Horsdal. Christian is an independent consultant and contractor, working with clients to improve their ability to deliver software-supported solutions to business problems. This is done typically by helping them to improve their software architecture, their ability to deliver continuously, and their code quality. Over the last 7 years, Christian has focused on microservices, but has also worked on a wide variety of software throughout his 20 plus years as a software developer. He's currently writing the second edition of his book, Microservices in .NET, which is already out in early access. And there's going to be a chance later on in the show for you to win a copy of the book. So make sure you're listening and get those details jotted down. There's going to be 5 copies, I believe, up for grabs. So welcome to the Cynical Developer, Christian.
Thank you very much. Happy to be here.
Yeah, glad to have you on to talk about what most people would see as the new hotness. But as you say, you've been working on it for 7 years or more. And that hotness is microservices. Everybody wants everything to be microservices.
They still do, it seems like, even though it has been around for a while, and there's been, I guess, a lot of material and a lot of talk about what they are and how to approach them, and so on and so forth.
Yeah, so I'm surprised that they're still a thing. Are we not onto Pico services or Mu services or some other buzzword for really small architecture?
Well, I don't know. I guess we could be in looking at some places, but the pendulum can also swing the other way. And I guess in any case, I think there is still a relevance. I also kind of think that the micro part of microservices may be a little bit unfortunate, but that's the name we're stuck with. So I guess it's really about getting a service-oriented architecture with some services that are pretty much focused on doing one thing and doing it well, and that gives us some leverage to get a nice, flexible architecture that can have some really good properties over time. But there's a lot of gray area, of course, in what that means. So is it really micro or macro or Pico or whatever? I don't know. It's about getting some sizes that work and make us able to deliver some good solutions, really.
Yeah, sure. So it falls into one of those old adages of software development, and it's naming things is hard.
Yes.
And no matter what we pick, somebody's always going to complain about what we've called it.
Somebody is going to complain. That's true. That is true.
Yeah. And as you said there, it's basically a services-based architecture, which we already had, but you couldn't call it that because people would see it as one and the same thing. But let's take a step back there. For those that don't know what microservices are, could you give us an overview of what they are?
Well, I tend to say that a microservice is a service that handles one business capability and then exposes an API to the rest of the system that enables it to collaborate with other microservices to deliver business value. So that means a couple of things, and we've already touched on the point that it means that we're still talking about a service-oriented architecture because these are services. And I think there's a lot to still carry forward about what we've learned about service-oriented architectures. I think where the difference to sort of more traditional or old school SOA, service-oriented architecture, is that these are much more focused on doing one thing. So they're not so much around covering a whole area like sales. They're more focused on one side, on one thing within the sales department, one capability that they do. They let's say they prepare quotes for customers. Then you might have a quote service as a first approximation at least. And then over time you might figure out that you need even smaller services than that, or it can go the other way. I think that's also pretty much pretty important in working over time with the microservices architecture, that you're willing to change the boundaries and say we didn't get it quite right the first time, But at least compared to more traditional SOA, we're going for something much more granular. In order to get something that can be delivered fast, that can be replaced if we get the implementation wrong, that is just easier to hold in your head for a developer. So you get more of an agile, quick, continuous delivery type of development going around it than you might have gotten with more traditional SOA.
Sure. So microservices, I think that they require a certain level of maturity in a team to implement and to implement them well. But is that the same as your opinion, and why does it take that sort of maturity level?
No, I agree with that. It does, and I think the reason is really because there tends to be so many of these services, so there's a lot of moving parts, and that's also I'd say the main reason not to do microservices, is that if the domain we're working with doesn't really inherently have the complexity that justifies introducing the technical complexities we introduce with microservices, then we shouldn't do it. And those complexities do revolve around the fact that there are that you'll have many microservices over time. So if you have, say, 200 microservices, then there are a number of things that you probably have to do well. You have to do logging, monitoring, tracing, those kinds of things in a consistent way. And you probably have to centralize where you send those messages to, so you can have an overview of the health of the system, and you're able to debug the system. Probably have to have things like correlation IDs going through those log messages, so you can follow a request going through all the way through the system and see why does it end up in this state, and so on and so forth in debugging sense. With a couple of hundred microservices, no matter what you do, you're going to have a lot of deployments, just because there are so many moving parts there that you can deploy. So you probably have to be quite good at automating those deployments and at being able to repeat them and do them all the time. So that sort of touches on the fact that, in my view, you can't really do microservices without also introducing continuous delivery. So that's a maturity thing. You can't really do continuous delivery if you're not doing continuous integration. So you get into a lot of maturity things. You need some good automated testing. You need automated builds. You need automated deployments. You need some consistency around how you deploy. If you want to scale the automation up to that level, you need consistency around logging, monitoring, these things that I mentioned before. So yeah, I'd agree. There are quite a few things that are needed maturity wise.
Yeah. So I guess off the back of that is that if you haven't built a system like this before or worked with a system like this before, would it be wise for a new project to be built as a monolith to start with?
Well, can be. I'm not in the camp of saying you should always start with a monolith and then cut it up into microservices. I think there are situations where a team can know that there is inherently complexity in the domain they're working with, and there are some lines they can draw where responsibilities fall in different categories. And in such situations, I think it does make sense to start out building services. Whether they are necessarily micro, that gets into the opening discussion we had about, is it micro, is it pico, is it macro? And I think the point is really, again, having some services that make sense. And I do find that can change over time for a system. So if we're talking about a team that hasn't done microservices before, it might make sense to start with slightly larger services to get a grip on how to work with services, how to do the automation and so on. And then if that works out well, then they might find down the road that, we actually want these to be even smaller, and then even smaller. That's at least a pattern that I've seen a few times. Whether that generalizes sort of very much, I'm not sure, but I've seen a few cases of that.
Sure. So I've worked with several micro service architectures, and they all seem to follow the same pattern. Is that I'm a .NET dev, so they're all .NET services in one way, shape, or form. Obviously, more recently, .NET Core services, and they could be things like Azure functions, and they react to topic events on a service bus. Now, do all microservices need to be event driven like that, or can they talk directly to each other?
I think preferring an event-driven approach in a microservice system is the right way to go. But I don't think we need to say that all the microservices have to be event-driven all the time. I'm okay with them sending some commands to each other and having the odd query from one service to another. But it is certainly something to keep an eye on, because it does introduce a lot more coupling between the services if we do commands and queries as well, compared to how it is with events. So that is a preferred one. I like to also try to use some domain-driven design along with microservices. So for domain-driven design, we have the concept of a bounded context. And in my experience, over time at least, the bounded context will each have several microservices sort of inside them. So that gives a grouping to the microservices, and I tend to accept some more coupling between services that are within the same bounded context. And then if you sort of cross from one bounded context to another, I'm more religious around making sure that we're taking an event-driven approach and keeping the coupling low. So I think that's sometimes a rule of thumb. But I certainly do prefer the event-driven. But yeah, it's all pragmatic when it comes down to it.
Sure. Yeah. So something that you mentioned there was the single bounded context, or for people that don't understand that, I'd say a single purpose. Are microservices always going to be that single purpose, that single bounded context, or can they be bigger than that? If I was creating a service that was dealing with orders, should I create several services? So like a create order, a read order, an update order, and a delete order service. Should there be 4 separate services, or should it just be a service that deals with orders in its entirety?
For that kind of thing, I'll go with one that deals with orders in its entirety. So you can create, read, and delete them all the way through if you actually want to delete something like an order. But there's a lifetime to something like an order. So I could see, so building up the shopping cart that might become before an order, if we're talking about an e-commerce system, I'd say that shopping cart is a separate thing. And then once the customer wants to buy something, that then creates an order in the order service. And that could be an event from a shopping cart service that says the customer submitted the cart and paid and so on. And that results in the order service picking it up and says, hey, there's a new order. And then maybe once that order is, that looks okay, and the order service says that everything is as it should be around that, then there's another event. That goes to an order fulfillment service. So that's still something to do with the order, but I could see fulfillment being a separate thing. So you actually send out the goods and so on and so forth. And once they have been sent out, some event could come back to that order service that changes the state of the order and says, now it's done. And again, that might trigger something in I don't know what we're talking about, 5th service now or something like that, that if you have something going on after the order is done for archival reasons or after sales or some kind of service offer that you want to give to the customer, those kinds of things go into separate services. So the responsibility of that order service would be handling taking responsibility for the lifetime of the order from after the order is placed. That's after they pay from the shopping cart and until it's fulfilled, but in collaboration with other services. Does that clarify your question?
Yeah, it does. And we talked there about moving that order around between different services. Would you send that order in its entirety in the message? So you've got like a God object of an order, and that would continuously go around with every message, or would you just send a reference to it for these services to go and pull it from a single master database?
I would probably send the reference. Over time, I think I've become more and more in the camp of sending around the reference, so that order service can have whatever internal IDs it wants in its database, but there's an external order ID, and for an order there's probably a natural ID, because there's an ID that the customer gets as well for that order. So that would probably be the reference that we pass around with events, and then those events should carry some semantics. So they shouldn't just be like order updated, and that can mean anything. It's like order placed, or order fulfilled, or order cancelled. These kinds of things. The event type tells us something about what's going on with this order. Again, I've seen how much data we'd want to put into those events. I've seen different things, and different things work. So some systems I've seen only have that ID, and then you have to query to get the current state of the order. Others go somewhere in between, where it's not the whole order, but there's maybe, like, if it's an order cancelled event, there's the ID and then a reason for the cancellation. Or if it's an order line added, then the order line might be included in that event. So that's a little bit of, and I think both can work. There's some consistency around maybe trying to do only one of the things. If there's a little bit more data, then other services might be able to react to the event without having to reach out and make a query to another service. So that's good for keeping the coupling down. On the other hand, the more data there's in there, the bigger the contract between the services becomes, and that's also a source of coupling. So this is again something to weigh system by system, really.
Yeah, I guess it's a trade-off.
It's a trade-off, yes.
Where your coupling's going to be.
Yes.
I know that I've implemented both ways, where we just pass around a reference in the event, and you have different event types, and those event types are very specific to a certain functionality, and different services will react to those different events. But then also sending around the main object, if you like, in the event as well. I guess it also depends, what it is you're doing with that information.
Yes, there is some use case specific stuff around it as well. Because there's definitely an argument to be made for having events that enables the other services to just look at that event and do their work, so they don't have to sort of reach out into the world and then gather some data in order to be able to do whatever they want to do.
Sure. So if we take it that we're just passing around an event with an ID or a reference to the master object or the master data, however you want to phrase it, is it okay then for these microservices to share at least a database for this data, or would you have to have some sort of synchronous communication with another service that pull that data back?
I would have the synchronous communication with another service. This is one of the points where I'm pretty adamant that I do not want the services to integrate through a database. So I don't want them to have a shared database, because I think that creates potentially a lot of coupling, and it's coupling that's difficult to see. Because if they share a database schema, then easily becomes this hidden coupling where something works because another service always does certain updates to the database, and it's just not clear what the consequences of those updates are. it's clearer that sending out an event is an interface to other services, just like it's clearer that listening for an event is an interface to other services. It's also clear that making an HTTP request to get some data back from another service, that's coupling, and that's an interface to another service. So I find that it's much easier to reason about the coupling that we have in the system and where those connections are if we keep it on the API level as opposed to on a database level.
This episode is sponsored by Honeybadger. So let's face it, your code is going to have errors. Even code written by such an amazing developer as myself is going to have problems. And when those errors do creep in, it's nice to know that Honeybadger's got your back. Honeybadger makes you a DevOps hero by combining error monitoring, uptime monitoring, and check-in monitoring. And that's all in a single, easy-to-use platform. And all way less for what you're probably paying now. If you're paying anything, because are you monitoring? You probably should be. Honeybadger monitors and sends alerts real time with all the context needed to see what's causing the error and where it's hiding in your code so you can quickly fix it and get back to being awesome. The included uptime and check-in monitoring also lets you know when your external services are having issues or your background jobs maybe go missing or they just silently fail. So go to honeybadger.io and discover how Star, Josh and Ben created a 100% bootstrapped monitoring solution. Why is this important? Self-funding means that they only answer to you, the developer, rather than a venture capital overlord, so you're in control. So go check out Honeybadger after the show, tell them the Cynical Developer sent you when you're signing up, and they'll give you 30% off for 6 months. The discount will be applied to your account and no credit card is required. But for now, let's get back to the show. But just one more thing before we do get back to the show. It's competition time, come on. All you have to do to enter the Microservices in .NET Core book giveaway is to simply head over to cynical.dev/microservices 2nd edition, and that's 2ND edition. Enter your email address and I will randomly pick the winners from that list. Now there are 5 digital editions of the book to be given away. And the winners will be contacted before the announcement to get consent for use of their names, and then the announcement will be made on Twitter, so make sure you're following us over there. All the links are in the show notes, so don't think you've got to try and remember that link. So that leaves me with to say good luck, and now it really is back to the show. Everybody talks about the benefits of microservices, which are the ability to deliver quickly, continuous delivery. We can swap out different pieces of the system as and when we need to. If one particular part of the system is becoming overloaded, we can add in more versions of or more instances of a particular service, and it will pick up and share those events and share the workload. Mm-hmm. But people very rarely talk about what the downsides are. And since this is the cynical developer, I want to know about the downsides. Why shouldn't I be implementing microservices?
Well, one of your questions earlier was around the maturity that we need to be able to do microservices, and I think that mirrors the downsides, which is really around the number of moving parts you have. Again, if you have a few hundred microservices, that means that there are a few hundred deployable units that you have running in your production environment that you need to monitor. You need to trace what's going on through them. You need to sometimes debug them. You need to keep an eye on the logging from all of those. And that needs some maturity to be able to build up systems in order to do that. And just the phrase that build up some systems that enables us to do that shows us that there is work in supporting all these microservices. So when we buy into microservices, we gain something around implementing the business logic and keeping that nice and separated, so on. But we also give ourselves some tasks around building some infrastructure that enables us to support all these microservices, and that's not insignificant work. So there's definitely adjustment to be made around: is it really worth it for the system? Is it going to live long enough? Is there enough inherent complexity in it, or are we just sort of putting a lot of accidental technical complexity on top of it by doing it in microservices. And just sort of from my own little world here, I'm currently working with 2 different systems. One is a system that we are slowly moving from a monolith to a microservice, and that's a system that has some years behind it, and there's definitely a lot of business logic and complexity there, so I do think that's the right move. I'm also working in a much smaller setting where it's actually not that complicated, the system really, when it comes down to it. The complicated part in that is more on the business side and actually figuring out what the right thing is to do. But technically, it's not a very complicated system. And for that one, we're sticking with the monolith because I think that's going to be faster for us to do for the foreseeable future. So even though I'm writing a book on microservices, I don't always think it's the right choice.
Okay. So you mentioned there that you were replacing a current monolith with microservices. That must be a hard task, depending on how well or poorly designed and created the system is that you're working with. Would you suggest that that's where a team new to microservices starts? Or would you say go and build a greenfield project with microservices?
Oh, I think that's difficult to answer, and I guess it's also difficult because I guess most team have a business problem to solve, and whether that includes some an older brownfield application or whether that's completely greenfield, I guess depends on the business. But I do think both scenarios are possible. And are fine. I wouldn't advise against starting out with microservices. But again, think about it and actually think, does it seem to justify building up that infrastructure that we need to support it? Like, do we really need a Kubernetes cluster? Or do we just need like an Azure website with some API endpoints? Do we just need a couple of functions? Or do we need to sort of spin up this whole thing? Do we need log aggregation and so on? Or could we just sort of go to one place and look at what's going on? What's the complexity of the system really, and of the business problem that we're trying to solve?
Yeah.
So that's kind of a non-answer to your question.
Yeah. I think one of the implementations that I've worked on more recently for microservices, it was Azure Functions, as I mentioned earlier, reacting to topics on the Azure event bus, and I think that works really well for that implementation that we were working on. And it wasn't a case of spinning up thousands and thousands of microservices. They were slightly larger than what some people may see as a microservice, but they had specific roles, and there was probably a couple of hundred lines of code in each one. So that's
not big at all, and that's really the point, is getting to something that works for the system. And that's why, well, I do see why it was made microservices, and there's some good around that, but it's also in some ways unfortunate because we always have this focus around the size of the service, and it's really about. And I think the boundaries and the responsibility of the service is more interesting than the size. So if we get some good responsibilities that make sense, then we can get a really nice system to work with. And that might mean that some of the services are slightly bigger and some are slightly smaller, and that's fine. It doesn't mean that the smaller are better. It's just different.
Yeah. And I found that one of the hardest parts of implementing a microservice architecture is not necessarily the implementation itself. It's explaining to the team that haven't worked with microservices before how that communication happens, how each service reacts to each other, and the fact that you've got to wait for this and then to do this. And it's, because a lot of people come from a monolith background where you make a call to a method, you get a response.
Yes.
Whereas in some microservice world, it's make a request to another endpoint, if you like, and then you're done. That's it. You have another endpoint that then reacts to the response that comes back onto the event queue.
Yep.
And that paradigm shift is always a bit of a sticking point for people.
Yes, there is definitely moving to a more event-based system and event-based architecture. That can be a paradigm shift. I agree. I think another point in sort of introducing this to teams is that I'd say for teams starting out, I'd rather err on the side of making the services slightly bigger than they need to be, than smaller than they need to be, because I do find that that's more manageable for a while at least, and then I've also find that it's not necessarily that hard to cut a service into a couple of pieces, because within the single code base, so if we're talking about a .NET code base, within a solution in Visual Studio, Writer, whichever IDE you want to use, it's pretty easy to refactor and move code around into separate namespaces. And then once you have that, and you can see that, there's a nice responsibility in namespace A and a nice responsibility in namespace B, then you can cut those into two different services. Whereas I find if we make them too small up front and put those in different solution files, and even maybe in different Git repositories, then moving that code around is just more cumbersome, and then you have to think about, if I move this code, can I then still deploy both of those services separately? And it just becomes harder. So at least for starting out, I'd rather see teams making them a bit smaller, and then over time figuring out what's the right size for us, than going the other way.
Yeah, that dependency on models between services, so they don't actually know about each service, but they know about the model that's going to be used between them, and trying to manage that dependency is always a bit of a sticking point.
It is.
Because you have service 1 that puts out model X, and you just updated all the properties on that. You've now got to go and work out which services actually consume that model X and update those ones as well. So that's always a fun game for trying to work out your continuous integration and continuous delivery. I know that you talked there about having things in single repositories or multiple repositories. One of the systems that I've been working on is microservice architecture, and it's all in separate repositories, which has caused us some problems because of those dependencies. And we have looked at it a couple of times and thought, should we move this into a single repository, because it'd make things so much simpler?
Yeah, and that might be the right way to go. I do tend to put each service in its own repository, so there are multiple repositories. But other people also have success with the bigger repositories. I don't know. I tend to think that introduces a bit of a risk again to having some more or less hidden coupling, because it's just kind of easy to share code in slightly weird ways. But again, I don't know. There's also, you're right, there's also some complexity in setting up those pipelines for all those different repositories. So trade-offs again.
Yeah. As with nearly every topic that we ever discuss, it's always an answer of, well, it depends.
It depends. That's the consultant's answer.
Yeah, I want, for one, do like the separate repositories just to stop developers abusing the code.
Yeah.
And like you say, adding in those references where they shouldn't be, and things like that. That's always been something of a problem, and I hate developers doing things like that they shouldn't really be doing. And if I can get in the way of them doing it, rather than outright just saying, stop doing that, you're causing me issues, then it's always good.
Yeah, that's much more effective. And I guess when those references are added that maybe shouldn't have been added, it's never a case of not wanting to do the right thing. It's a case of, that was right there and we're under pressure, and I didn't know that there was a rule that says that we shouldn't do that. So you're right. It's sort of about making it easier to do the right thing than the wrong thing.
Yeah. both myself and yourself, we are .NET developers, but that sort of means that whenever we'd probably look at building these sort of systems, 95%, if not more, of the time, we would go, right, well, we'll just write this in .NET. But I've heard a lot of people say, it doesn't matter, you're doing microservices, we can write it in any language you like. We'll have some .NET ones, we'll have some Go ones, and things like that. Is that a real world scenario? By doing that sort of thing, are you not just introducing a higher level of complexity? And it's complexity you just don't need, because going in as a consultant or a contractor, and you go, well, we'll do these ones in Go and these ones in this language and that one in that language. When you leave, because you're the person with that experience, that company's got to go in and hire people with all those skill sets to manage them. So, I think that's a very long-winded way of saying, should you write them all in the same language, or is it all right to do it in whatever language takes your fancy, a bit of resume-driven development?
Yeah. No, I think for most teams and most situations, you should write it in, if not one language, then a few languages. I guess for large setups where there are many teams, it makes more sense to allow more different languages, and then over time you might see clusters appearing that sort of in this end of the system it tends to be Node, and in this end it tends to be .NET, and over here it tends to be Go or whatever. But I think a lot of companies are not that big, and they have maybe let's say 5 teams working on different microservices, or maybe even 10 teams, and for that kind of size, no, I don't think it makes sense to make it really free for all. So I do tend to encourage clients to standardize on something. Not necessarily just one language or one platform, but a couple. So you might say that we do .NET and we do Go, just because maybe some of our things has something performance critical where we think we can do a better job in Go than we can in .NET. Or you might say that we're doing some in .NET. That will cover a lot of things, and it's nice for a lot of business functionality, but we're also allowing some in Python because that works well with a lot of big data kind of tools and number crunching tools, data science kind of things, and that might be important to us as well. So I can see you sort of picking a couple, but I do agree that it's unnecessary complexity to just have all kinds of languages in there.
Sure. One thing that I've seen online through social media, such as Twitter, is this movement of late, which is to go back to monoliths. Is this a case of people saying they don't do monoliths for the sake of saying they don't do monoliths, and for the sake of arguments? Is it a tabs versus spaces scenario?
I think it's a bit more than that, but I think it's more of sort of a hype cycle thing, I guess, that we are at the point where a lot of people have implemented microservices, and some have had success and some haven't, and then there's a backlash from the people who haven't. And why haven't they had success? That can be for a number of reasons, and one of them being that it isn't relevant for all systems. So they might be absolutely right that it's much better for that system to be a monolith. So yeah, I think it's a pendulum swing that we sort of see, that maybe the industry goes a bit overboard with microservices for a while, and then we swing back a bit, and hopefully over time we sort of find a better and better balance.
Yeah. Do you think that some of these people that are out there saying that they're bad, they've been bitten by microservices, but it's not necessarily the technology itself. It's probably the poor implementation. Maybe the person that implemented it didn't quite understand it, or the time pressures that they were under didn't allow them the correct time to learn how to correctly build that sort of microservice.
That's certainly a part of it. That time pressure and so on means that maybe people sort of haven't done it quote unquote right. But I would also expect that there's also actually some resume-driven development in there, looking at a system and saying, this could be a monolith, it could be microservices. Let's do it microservices. That's better for the resume. Maybe that's not a conscious decision, but that's the cool thing to do. And then maybe it turns out that, it wasn't that complex and it would probably have been better as a monolith.
Yeah, sure. So we mentioned at the very start there that you are on your second edition of your book, Microservices in .NET. For the listeners out there, do you want to give an overview of what your book is about if they haven't already read the first edition?
So it's a developer focused book. It's a practical focused book around how to build microservices. It's a sort of secondary audience, I guess, is architects. But there is a lot of developer material in there. So it's about what microservices are and how to actually really implement them using .NET. So there's stuff around founding these boundaries and defining them well. There's stuff around how to implement the data storage, how to implement the collaboration between them in a robust way and keeping the coupling down. There's stuff around testing the microservices both individually and some around the doing at the system level. But again, it's a developer focused one, so actually more focus on testing each microservice individually. There's stuff around building some security into these microservices, and again around how they collaborate. So it's a practical guide to finding good boundaries, implementing good microservices that you can work with over time, that are secure, that gives you what you need in terms of being able to do the monitoring, so on, but that they need to be somewhat alike to do that, and how to test them and so on, so you get a manageable system. The chapters tend to be one half, if not theory, then at least sort of the concepts on a sort of words and drawings level, and then there's a half where we go into some ASP.NET Core code and some C# code and see how that's done in practice, and goes into some Kubernetes stuff around how to set these services up in Docker containers and run them in a Kubernetes cluster that we set up on Azure. So it becomes very practical as well.
Awesome. So it's .NET Core rather than Framework.
Yes.
So
it's probably going to be .NET 5 before the second edition is done. I'd imagine.
Sure. So if you haven't already started learning about it, or even if you have started learning about it, then do get out there and have a look at Christian's book. There, it should be interesting. I will undoubtedly be thumbing my way through that book at some point in the near future. I look forward to that coming out. If our listeners aren't yet working with microservices, where would you say is the best place to start that isn't buying your book?
That isn't buying my book. I would. Well, the obvious and very good choice is Sam Newman's microservices book, which is really, I think, the core book around microservices, and does a really good job of explaining what they are and how you work with them. So that I'd say go read that one. That's then you're off to a very good start.
That should give you the foundation of what microservices are before you go and start implementing them.
Yes. So you understand the architecture and the ideas behind them. And then maybe after that, looking at the maturity that we talked about, then reading the continuous delivery book by Dave Farley and Jess Humble, as far as I remember. This is off the top of my head. I think it's also very good because that's very closely related and gives that maturity needed to do the microservices. So those would be two very good books to start with.
Awesome. Thank you very much. So we're just about out of time. So that leaves me with just to say thank you for coming on and talking to us about microservices. I think it's a really good topic, and it's a really interesting paradigm to work in. So thank you for coming on and sharing that. Hopefully the listeners got a lot from it.
Thank you for having me.
Yeah, not a problem. And thank you to everyone out there for listening. I'm James Stoddart, and you've been listening to Christian Horsdal talking about microservices. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website, where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.